Okay, so let's dive right into this True Serum paper.
Truth Serum, poisoning machine learning models to reveal their secrets.
Right, yeah, Truth Serum, poisoning machine learning models to reveal their
Wrong with
secrets.
that?
And forget those spy movies, right? This is about real-world vulnerabilities in machine learning privacy.
Absolutely.
We're talking data poisoning attacks, but with a bit of a twist.
Yeah.
So instead of just messing with a model's accuracy,
Right.
these attacks can actually pull out private information straight from the training data.
Yeah, it's a very clever approach. The researchers call it Truth Serum because it forces these seemingly opaque models to give up their secrets.
Okay.
And given your work with sensitive data, I think this vulnerability is something you should be aware of.
So how does this Truth Serum actually work? I mean, data poisoning usually means you're trying to make a model less accurate. How do you flip that and make it leak information?
Well, you got to think about it like this. Security and cryptography really rely on this idea that if you can break a system's integrity, you can often find a way to then break its privacy.
Right.
Classic examples in cryptography like padding oracle attacks or compression leakage attacks.
Yeah.
They really demonstrate how if you can manipulate the data, you can get it to leak information. And Truth Serum is kind of applying that principle to machine learning.
Okay, so we're talking about exploiting vulnerabilities in the model's integrity to pull out information about the training data.
Exactly.
But how do you actually go about doing that?
So the researchers frame it as a privacy game.
Okay.
So in a traditional setup, the adversary is trying to guess which piece of data from a specific universe was used to train a model.
Right.
So think membership inference or attribute inference or even, full-on data extraction.
Yeah.
But in the Truth Serum game, the attacker actually gets to poison the training data beforehand.
Right.
And that makes their job a whole lot easier.
Interesting. So it's not just about observing the model's behavior. It's about actively manipulating it to leak information.
Exactly.
But how does that manipulation work?
Right.
Is it just like stuffing the training set with a ton of copies of the target data?
So that's a common misconception.
Oh.
Simply maximizing memorization doesn't actually help distinguish between models that were trained with or without the target data.
So if it's not memorization, what is it?
It's all about maximizing the target data's influence on the model's behavior.
Okay.
Let me give you an example.
Yeah.
Let's imagine a k-nearest neighbors classifier. You can poison the training data by strategically adding in points that essentially act as a tiebreaker when classifying the target data.
Okay.
So if the target was in the original training set, the model will classify it correctly.
Right.
But if it's not, it'll get it wrong.
Yeah.
So membership is perfectly revealed.
That's a pretty clear example. So you're manipulating the model's decision boundary to make the presence or absence of the target data really obvious. But how does this translate to the more complex world of deep neural networks?
Right.
I mean, I imagine achieving that level of control is a lot harder.
It is. It's very hard. You can't always engineer such precise control in deep neural networks. So instead of targeting every single data point, Truth Serum focuses on outliers.
Okay.
Because outliers naturally have a stronger influence on the model's behavior.
They stick out.
They sort of, exactly. So the attack aims to turn the target data into an outlier, even if it wasn't one originally.
Right.
Do they modify the target data itself to achieve that?
Surprisingly, no. They use a technique called label flipping.
Okay.
So they poison the training set with mislabeled copies of the target data.
Oh, interesting. So the model learns the wrong association, and then when it encounters the actual correctly labeled target data, it's like, wait a minute, what's going on here?
Right.
And that makes it stick out like a sore thumb.
Exactly.
Clever, clever. Did they actually test this approach out on any real data sets?
They did.
They tested it on CFAR 10 and CFAR 100.
Okay.
And the results were really quite dramatic.
Whoa.
So on CFAR 10, by poisoning just 0.03% of the training set,
Wow.
they boosted the true positive rate of a membership inference attack from 7% to 59% while keeping the false positive rate low.
Okay.
On CFAR 100, the true positive rate jumped from 22% to 69%.
Wow. That's a huge improvement.
It is.
So even a tiny amount of poisoning can really make a big difference in the success of these attacks.
It can.
You mentioned that Truth Serum focuses on outliers.
Yeah.
Does that mean that all data points are equally vulnerable to this label flipping technique?
That's a good question.
What about data points that weren't outliers to begin with?
So that's a really crucial point.
Okay.
Their research actually shows that data points that were initially safe from membership inference, what we call invers,
Right.
they become much more vulnerable to these attacks after poisoning.
So even if my data isn't an outlier, an attacker could still specifically target me and still infer membership successfully. That's a little worrying. It's like this attack eliminates the distinction between outliers and inliers,
It does.
making all data points equally susceptible to this type of attack.
That's right. That's one of the big findings of this research.
Okay.
This attack levels the playing field,
Yeah.
turning previously safe data points into outliers and making them just as vulnerable as naturally occurring outliers.
And this is where it gets interesting. We often rely on shadow models to calibrate these kinds of attacks, but the paper suggests that truth serum might change that,
That's right.
right?
Yeah, so shadow models are used to try and distinguish between normal model behavior and behavior that has been influenced by the target data. But with truth serum, the label flipping itself creates kind of a universal calibration.
Interesting.
So by pushing the model's confidence on poisoned data points to very low values,
Right.
it makes the presence of the correctly labeled target stand out even more.
Right.
It's like a beacon.
So the attack itself provides the calibration needed for the inference. That's pretty elegant.
Yep.
Does it actually work as well as using shadow models?
That's a good question. So they found that with poisoning, a simple global threshold on POS, the confidence was enough to achieve almost the same attack accuracy as using 128 shadow models.
Wow.
Yeah. And they also looked at the impact of the specific choice of the incorrect label.
Okay.
And they found that as long as the incorrect label is used consistently for all of the poison copies, the specific choice doesn't significantly affect the attack success.
Interesting. So picking a random incorrect label works just fine.
It does.
That makes the attack even simpler. What about scenarios where you don't have perfect knowledge of the target data point?
Right.
Did they consider that at all?
So they tested that on CIFAR 10s, simulating partial knowledge of the target image.
Okay.
And they found that both the baseline attack and the poison attack remained effective.
Interesting.
Even with only a partially obscured image,
Wow.
they could still successfully infer membership.
Okay, so this isn't just a theoretical attack. This could work in real-world settings where you might not have perfect information.
Exactly.
That's concerning, to say the least.
Yeah.
Are there any defenses against this type of attack?
Mm-hmm.
I mean, if someone's trying to poison my model to extract my data, what can I do?
So they explored a few mitigation strategies.
Okay.
One was limiting the influence of outliers during training using a technique called loss clipping.
Okay.
Essentially, they bounded the maximum loss that any single data point could contribute during training.
That makes sense.
Yeah.
If the attack relies on turning the target data into an outlier, preventing outliers from having such a large impact should help.
Right.
Did it work?
It worked to some degree. So loss clipping did reduce the targeted attack's effectiveness, especially with multiple poison copies.
Okay.
However, the baseline membership inference attack without poisoning still had a relatively high success rate.
Right.
And even with more aggressive loss clipping, which brought the baseline attack down to near chance levels,
Okay.
poisoning still improved the attack's success rate.
So even with really aggressive clipping, the attacker still has an edge.
They do.
And like we discussed earlier, aggressive clipping hurts model accuracy, right?
It does. Unfortunately, they saw a 45% increase in the model's test error rate.
Yeah, that's a steep price to pay for a little bit more privacy protection.
It is.
Plus, they found that untargeted attacks, where the goal is to increase the leakage of all data points in the training set,
Right.
are actually resistant to loss clipping.
They are.
Untargeted attacks. That sounds even more challenging to defend against.
They are. They require the attacker to control a larger portion of the training set, though,
Okay.
which is more realistic in collaborative training scenarios like federated learning or MPC.
Interesting. So if the attacker controls a significant portion of the training data, they can potentially increase the privacy leakage for all the other data points in the set.
Exactly.
What about defenses against these untargeted attacks?
Right.
Does loss clipping help at all?
So they found that moderate loss clipping had no effect on the untargeted attack. And as we saw before, stricter clipping hurt the model's accuracy.
So it seems like we're stuck between a rock and a hard place.
A little bit. Yeah.
We can sacrifice accuracy for a bit more privacy, but even that might not be enough.
Right.
This truth serum attack really does exploit some fundamental weaknesses.
It does.
But all of this discussion has focused on structured data like images.
Mm-hmm.
I'm curious, how does this all play out in a less structured data domain like language modeling?
That's where their research takes an even more fascinating turn.
Okay.
They investigated how these poisoning techniques could be used to extract secrets from language models.
Secrets.
Secrets.
That sounds a bit more like something out of a spy movie.
It does.
How do they go about doing that?
So they use this concept of canaries, which are specially formatted strings that are inserted into the training data.
Okay.
In their case, the canaries were a known prefix, followed by a random 6-digit number, simulating like a secret PN or a code.
Right.
And the attacker's goal is to extract that 6-digit canary from the trained language model.
Okay, so they're trying to extract specific information from the model.
Right.
But why is that even possible? Wouldn't the model just treat the canary as any other random string of text?
So they first tried a very simple attack where they ranked all possible canary values based on the model's loss,
Okay.
assuming the model would assign a lower loss to the actual canary it was trained on.
Right.
However, this approach wasn't very effective.
They're not.
Well, language models have a lot of pre-existing biases.
Right.
Common numbers like 1, 2, 3, 4, 5, 6 generally have lower losses than random 6-digit sequences, even if those random sequences were part of the training data.
Okay.
It's a calibration issue.
Right.
The model's inherent biases overshadow the subtle signal from the canary.
So how do you address this calibration issue?
Right.
More shadow models.
Shadow models are one approach.
Okay.
They found that calibrating the attack with even just 2 shadow models significantly improved the canary exposure.
So shadow models help, but they also explored poisoning techniques in this context of language models, right?
They did.
What did they find?
So they came up with 2 strategies:
Okay.
prefix poisoning and suffix poisoning.
Okay, let's start with prefix poisoning.
Yeah.
What does that involve?
It's pretty straightforward. The attacker gets to choose the prefix that precedes the secret canary,
Okay.
manipulating the context in which the secret appears.
So they can control what comes before the secret they're trying to extract.
Exactly.
Does that actually make a difference?
It does. They found that using out-of-distribution prefixes like random strings of characters or even code snippets
Okay.
dramatically increased the canary's exposure.
Yeah, I guess that makes sense. The model is less confident in predicting what comes after those unusual prefixes, so the signal from the canary becomes stronger.
Exactly.
But prefix poisoning assumes you have a lot of control over the data.
Right.
What about cases where the attacker can't choose the prefix?
That's where suffix poisoning comes in.
Okay.
So in this attack, the adversary knows the prefix but can't change it.
Right.
Instead, they inject multiple copies of the prefix into the training data,
Okay.
but each copy has a different arbitrary suffix after it.
Okay.
Essentially, they're mislabeling the canary.
It's like repeating the pin is 0000000 over and over again.
Exactly.
Flooding the model with incorrect information, which then makes the actual canary with its unique 6-digit sequence stand out even more.
Exactly.
Did they find that this approach was effective?
It was suffix poisoning significantly increased canary exposure even without any prefix manipulation.
Incredible. So they can manipulate the context both before and after the target secret to make it easier to extract.
They can.
What happens if they combine both prefix and suffix poisoning?
That's when truth serum really shines.
Okay.
Combining both attacks led to a 39-fold reduction in the number of guesses needed to extract the canary compared to no poisoning.
Wow, that's a huge improvement. It makes you wonder if there are any limits to what an attacker could extract with this approach.
Yeah.
But all of this assumes that they know the entire prefix preceding the canary, right? What if they only have partial knowledge?
They tested that too. They simulated an attacker who only knows the last few tokens of the prefix.
Okay.
And as long as they had enough context, they could still successfully extract the canary with poisoning.
So even partial knowledge of the prefix combined with poisoning is enough to compromise the model.
That's right.
Are there any other assumptions that they challenged?
Yeah.
What about the reliance on shadow models for calibration?
Right. So they found that poisoning the model provided roughly the same benefit as using shadow models for calibration.
So an attacker can achieve pretty significant gains in canary exposure just by poisoning the training data,
Exactly.
even without shadow model.
Exactly. Which makes the attack even more practical.
Right.
Especially since poisoning large language models might be easier than training shadow models from scratch.
This research is fascinating. It seems like truth serum is quite a potent weapon in the hands of an attacker,
It is.
highlighting this crucial link between data integrity and privacy in machine learning.
It is.
This is clearly a significant concern, especially as these models become more prevalent and we're entrusting them with more and more sensitive information.
Absolutely. It's a real wake-up call for anyone working with sensitive data in machine learning,
Yeah.
particularly in collaborative settings where ensuring data integrity across all the different parties is a really significant challenge.
It really underscores the need for robust data validation and sanitation procedures, even in seemingly secure environments like federated learning.
Yeah.
Speaking of security concerns, all this talk about poisoning reminds me of backdoor attacks.
Mm-hmm.
Are there any connections between truth serum and backdoors?
That's an interesting point. Both attacks involve manipulating training data to influence the model's behavior.
Right, but are the goals the same?
Not exactly. So
Oh.
backdoor attacks aim to create a hidden trigger that causes the model to misclassify specific inputs.
Okay.
For example, an attacker could add a specific pattern to an image
Right.
that forces the model to always classify it as a certain object, regardless of what the image actually shows.
Right.
They want to maintain the model's overall accuracy while injecting this vulnerability that they can exploit later.
So backdoor attacks are about controlling the model's output for specific inputs.
Exactly.
How's that different from truth serum?
So truth serum isn't about misclassification.
Right.
It's about maximizing the leakage of private information from the training data.
Okay.
It's not about controlling the model's output. It's about exposing its inner workings.
That's a helpful distinction.
Yeah.
So backdoor attacks focus on control, while truth serum focuses on exposure.
Exactly.
They're both exploiting the manipulability of machine learning models during training, but for different ends.
Exactly. It really highlights the need for a holistic approach to security in machine learning.
Yeah.
We can't just focus on preventing one type of attack. We need to consider the whole spectrum, from poisoning to backdoors to traditional privacy
It
attacks.
seems like a constant cat and mouse game, with attackers often having the upper hand.
It can feel that way.
This truth serum research really raises some fundamental questions about the trust we place in machine learning systems, especially as we integrate them more and more into critical areas of our lives.
Yeah.
We tend to treat these models as black boxes,
Right.
assuming they're secure and reliable.
Mm-hmm.
But this research shows they can be manipulated in some very subtle ways.
They can. It's definitely a wake-up call. We need to be much more aware of the potential for manipulation
Yeah.
and take steps to ensure that our models are resilient to these types of attacks.
And this means moving beyond just focusing on achieving high accuracy.
Absolutely.
We need to start thinking about privacy and security
Mm-hmm.
as integral parts of the design process.
100%. A shift from security as an afterthought
Right.
to security by design.
Exactly. And this requires a change in how we approach machine learning,
It does.
from the algorithms we use to the ways we collect and handle data.
Absolutely.
So what are the implications of all of this for our listeners, for those working on the front lines of machine learning research and development?
Well, I think awareness is paramount.
Yeah.
We need to understand that data poisoning is not just about degrading model accuracy.
Right.
It can be this very powerful tool for extracting sensitive information.
So it's about being proactive, not reactive.
Exactly.
Don't wait for an attack to happen.
Yeah.
Take steps to protect your models and your data from the outset.
Exactly.
But what about defending against specific attacks like truth serum?
Right.
What concrete actions can researchers and developers take?
Well, as we discussed, mitigating the impact of outliers during training is crucial.
Yeah.
Techniques like loss clipping, while not perfect,
Right.
can offer some level of protection.
So limiting the influence that any single data point can have on the model's training process can help.
It can.
What about other approaches? What about securing the data itself before it's even used to train the model?
That's another really important aspect.
Oh.
Robust data validation and sanitation procedures can go a long way in preventing poisoning attacks. This involves carefully scrutinizing the data
Right.
for anomalies and inconsistencies and potential signs of manipulation.
Yeah.
Think of it like quality control for your data.
Okay.
You need to make sure that the data you're feeding into your models is clean, consistent, and trustworthy.
That makes perfect sense.
Yeah.
But even with these safeguards, it seems like attackers are constantly finding new ways to exploit vulnerabilities. It's a bit disheartening.
It can be. But it's important to remember that security is an ongoing process.
Right.
We need to be constantly learning and adapting and evolving our defenses to stay ahead of the attackers.
It's like an arms race where both sides are constantly developing new techniques and strategies.
Yeah.
But getting back to the truth serum research, we've talked a lot about membership inference.
Yeah.
What about other types of privacy attacks? How does truth serum impact things like attribute inference or data extraction?
So the researchers showed that truth serum, particularly the label flipping technique, could be adapted to enhance various other privacy attacks.
Okay.
For example, they demonstrated successful attacks on attribute inference, where the goal is to infer some unknown characteristic of a data point based on the model's output.
Could you give me an example of how that might work in practice?
Sure. Let's imagine a model that's trained on medical records
Okay.
to predict a patient's risk of developing a particular disease. An attacker with access to this model could potentially use attribute inference
Okay.
to learn sensitive information about an individual, like their genetic predispositions,
Right.
even if that information is not explicitly included in the model's output.
So it's like filling in the missing pieces of a puzzle, using the model's predictions to infer information that wasn't directly used in training.
Exactly.
Did the researchers find that truth serum could effectively enhance these types of attacks?
They did. They tested this on the adult dataset, which contains demographic information like income, education level, and marital status.
Right.
Their poisoned attack was much more accurate in inferring attributes like gender and relationship status compared to traditional attribute inference techniques.
Interesting.
Interestingly, without poisoning the attack was actually less effective than a simple imputation baseline.
What do you mean by imputation baseline?
So that means inferring the unknown attribute based solely on statistical correlations in the data
Okay.
without using the model.
Got it.
So in this case, the model itself, without poisoning, wasn't leaking more information than what could be gleaned from the data itself.
That's a bit reassuring,
A little bit.
but also a bit unsettling.
Yeah.
It means that the model in its unpoisoned state wasn't inherently vulnerable,
Right.
but it could be made vulnerable through this targeted manipulation.
Precisely. It underscores that the security of a machine learning model is not just about the model itself,
Right.
but also the data it's trained on and the
Yeah.
environment it's deployed in.
So a seemingly safe model can be turned into a privacy-leaking machine if someone can manipulate the training process.
Exactly.
We've also talked about data extraction in the context of canaries and language models.
Mm-hmm.
Did the researchers explore any other aspects of data extraction?
They did. They also looked at extracting high-entropy secrets from language models beyond those simple 6-digit canaries.
Oh, yeah.
They investigated the vulnerability of canaries in different contexts within a language model, looking at how manipulating the text surrounding the canary, both before and after, could impact an attacker's ability to extract it.
So it's not just about the canary itself, it's about the context in which it appears.
Exactly.
Did they find that the surrounding text had a significant impact on the success of these attacks?
They did. They found that certain types of prefixes, like code snippets or random strings of characters, made the canary much easier to extract,
Okay.
which aligns with what we discussed about prefix poisoning.
Right. It seems like the more unusual or unexpected the context, the more the canary stands out, making it easier to identify and extract.
Right.
What about manipulating the text that comes after the canary?
Yeah,
Did they explore that as well?
they did. They found that adding incorrect suffixes after the canary, like padding it with zeros,
Right.
could also increase exposure.
Because it creates that same kind of discrepancy,
Exactly.
making the true canary stand out from the manipulated ones.
Right.
It seems like they covered a lot of ground with these data extraction experiments.
They did.
Did they find any ways to mitigate these vulnerabilities in language models?
So they investigated various mitigation techniques, many of them inspired by differential privacy.
Right.
Which aims to guarantee that the output of a computation doesn't reveal too much information about any single individual's data.
Differential privacy is a fascinating concept,
It is.
but it often comes with a trade-off in accuracy.
Right.
Did the researchers find any defenses that were effective without significantly impacting the model's performance?
Unfortunately, there's no easy answer.
Right.
They did find some promising results.
Okay.
But like most things in security, it's a constant arms race.
Yeah.
As new defenses are developed, attackers will find new ways to circumvent them.
Right.
What's crucial is that we continue to innovate and improve our defenses to keep up with this evolving threat landscape.
It's a reminder that security is a journey, not a destination.
Exactly.
We can't just implement a few safeguards and call it a day.
Right.
We need to constantly adapt and evolve our strategies to stay ahead.
Absolutely. But beyond these specific defenses,
Yeah.
we need more fundamental changes in how we design and deploy these systems.
Yeah.
We need to move beyond focusing solely on model accuracy
Right.
and start thinking about privacy and security as integral parts of the design process.
So baking security into the very foundation of machine learning,
Exactly.
not just adding it as an afterthought.
Right. This requires a collaborative effort from researchers and developers and policymakers.
Yeah.
We need new standards and regulations that ensure that machine learning is used responsibly and ethically.
It's a complex challenge,
It is.
but one that we can't afford to ignore.
Absolutely not.
The potential benefits of machine learning are enormous.
Huge.
But we need to make sure that those benefits are realized in a way that respects individual privacy
Absolutely.
and protects our collective security.
100%.
And it's not just about protecting against malicious attacks.
Right.
It's also about building trust and transparency into these systems.
I completely agree. If people don't trust AI, they won't use it.
Right.
And then the potential benefits will be lost.
Exactly. This truth serum research is a really valuable contribution to this conversation.
It is.
It really highlights a vulnerability that I think a lot of people may not even be aware of.
Absolutely. It raises the stakes, doesn't it?
It definitely does. This isn't just some theoretical problem anymore.
Yeah.
It has real implications for how we build and deploy machine learning systems in the future.
It does. It's a challenge that we need to face head on. And research like this is critical.
Yeah.
By exposing these vulnerabilities, we can start to develop robust solutions and build more trustworthy AI systems that benefit everyone.
It seems like the Truth Serum paper is a bit of a wake-up call for the machine learning community.
It is.
It's pushing us to be more critical of the systems we build
Yeah.
and to prioritize privacy and security from the start.
Absolutely.
Yeah.
We often get caught up in the pursuit of accuracy, sometimes at the expense of other crucial considerations like privacy and security.
So how do we move forward? What concrete steps can we take to address these vulnerabilities and build more secure AI systems?
Well, I think it starts with a shift in mindset.
Okay.
We need to stop treating security and privacy as add-ons or afterthoughts.
Right.
They need to be core design principles baked into the very foundation of our models and systems. We need to develop new algorithms and training techniques that are inherently resistant to these types of attacks.
That makes sense. But algorithmic advancements alone might not be enough.
No.
What about the data itself? How do we ensure that the data we're using to train our models is clean, reliable, and free from manipulation?
Robust data governance is critical.
Okay.
This involves establishing clear procedures for data collection,
Right.
validation, and sanitation.
Right.
We need to be much more vigilant about data quality,
Yeah.
especially in collaborative settings where data is coming from multiple sources.
So it's not just about protecting against external attackers. It's also about ensuring that the data we're using internally is trustworthy.
Absolutely. We need to treat data with the same level of care and scrutiny as we would any other critical component of our systems.
That's a good point.
Yeah.
And this brings up another important aspect.
Yeah.
What about the role of collaboration and communication
Right.
in this whole process?
Right.
It seems like addressing these challenges is going to require collective effort.
It definitely will. We need open communication and collaboration between researchers, developers, policymakers, and even the general public. We need to share knowledge, best practices, and potential solutions.
Yeah.
And we need to be transparent about the limitations and potential risks of these technologies.
Transparency is crucial.
It is.
If people don't understand how these systems work and what the potential risks are, they're less likely to trust them.
Exactly. Building trust is essential for the widespread adoption and beneficial use of AI.
Right.
And trust is built on transparency, accountability, and a commitment to ethical practices.
So this research paper has really opened up a Pandora's box of challenges and considerations.
It has.
It's clear that we have a lot of work to do
We do.
to ensure that machine learning is developed and deployed in a responsible and secure manner.
Absolutely. But I'm optimistic about the future.
Okay.
We have a growing awareness of these issues,
Yeah.
and researchers are actively working on developing innovative solutions. The key is to stay vigilant,
Right.
to continue to push the boundaries of our knowledge,
Yeah.
and to work together to build a more secure and trustworthy future for AI.
Well said. This has been a fascinating and insightful deep dive into the world of machine learning privacy.
Absolutely. Truth Serum is a powerful reminder that even the most sophisticated AI systems are vulnerable to manipulation.
It really underscores the critical importance of data integrity, security by design, and a collective commitment to responsible AI development.
I agree. It's a call to action for everyone involved in this field. We need to be proactive, not reactive. We need to prioritize security and privacy from the outset. And we need to work together to ensure that this transformative technology is used for good.
Well said. This has been a fascinating and insightful deep dive
It has been.
into the world of machine learning privacy.
Absolutely.
Truth Serum is a powerful reminder that even the most sophisticated AI systems are vulnerable to manipulation.
It is. And it really highlights how data integrity is so crucial.
Right.
Security needs to be built in from the start.
Security by design.
Security by design, exactly. And it requires a collective commitment to responsible AI development.
Absolutely. We need to make sure that we are using this technology for good,
For good, exactly.
that it's benefiting everyone.
100%.
So thank you for joining us on this deep dive.
It's been my pleasure.
We hope you found it informative,
Yes.
thought-provoking, and perhaps even a bit inspiring.
A bit inspiring, for sure.
It's a complex landscape,
It is.
but by understanding the challenges, engaging in open dialogue, and working collaboratively, we can harness the power of AI safely and responsibly for the benefit of all
I completely agree.
into the world of machine learning privacy.
It has been, yeah. Truth Serum is a powerful reminder that even the most sophisticated AI systems are vulnerable to manipulation.
Yeah, it really underscores the critical importance of data integrity and security by design
Absolutely.
and, a collective commitment to responsible AI development.
100%. We need to make sure that we are using this technology for good.
For good.
Yeah.
Exactly. So thank you for joining us on this deep dive into the world of machine learning privacy. We hope you found it informative and thought-provoking and maybe even a bit inspiring.
Absolutely. Inspiring, for sure. It is a complex landscape, but by understanding these challenges and by engaging in open dialogue and working collaboratively, we can harness the power of AI safely and responsibly.
For the benefit of all.
For the benefit of all, exactly.
Well, that's it for this episode of The Deep Dive. We hope you enjoyed our conversation and learned something new along the way. Be sure to check out the show notes for links to the research paper and other resources mentioned in this episode. And as always, thank you for listening.